Hi, and welcome to Better Code Today. My name's Tim Neal, and today I'm going to talk about encapsulation, why it's important in software development, what it means for our software, and how we can use it to create better code. Encapsulation is a basic and fundamental concept in object-oriented programming. It's effectively the art of hiding certain aspects of our classes so that only the most relevant features are made available to be consumed by external code. Everything else is encapsulated within the class where it can't be accessed. This allows us to write decoupled code, as our class will expose a public API that we can work with, but we are completely isolated from the details of how that API is implemented. By writing properly encapsulated classes, we should be able to safely refactor the internal workings of a class as much as we like without breaking any external code. Ultimately, we're just hiding stuff that external code shouldn't be concerning itself with. Abstraction is another term that often comes up when talking about encapsulation. At its most basic, it's about creating a simple representation of something more complex. Think particularly of abstract art, which uses simple lines, shapes, and colors to represent a complex concept. In software development, abstraction is closely related to encapsulation, although while encapsulation puts the focus on hiding things away, abstraction is more about exposing an appropriate but limited subsection of those things. Of course, ultimately, in implementation, both become about making choices on what should be visible and what should be hidden, so it's not unusual for the two terms to be confused or used interchangeably. The concept of leaky abstractions was first described by Joel Spolsky of Stack Overflow fame, among other things. Basically, this happens when your abstraction or encapsulation breaks down. Either data you wanted to keep private becomes publicly viewable or modifiable, or some implementation detail becomes obvious to the user. Joel says that all non-trivial abstractions are leaky, and goes on to provide examples such as how any abstraction involving a network can't hide the fact that if you pull the cables, then the network will go down. This is not to say that we should give up on abstraction because it'll never work, just that we need to be aware that any abstractions will have its limitations. A common and avoidable cause of leaky abstractions in software is the exposure of complex member fields through methods or properties. Perhaps your class has a list of child objects and you want to make those children visible to external code. The obvious thing might be to create a property that returns that list. However, once the calling code has that list, it can add or remove children or clear the list entirely, which probably isn't what you want. This can be easily solved, for example, by creating a copy of the list each time it's accessed, but it's easy to be caught out. So here's a question. Why is it considered to be a bad thing to write classes like this widget1 class that have public fields, but okay to write classes like widget2 with public properties that basically just expose a private field? This is a question that stumped me for a long time as a young developer. After all, the end result is just the same. We can get and set that data in exactly the same way from external code as demonstrated in the example shown, regardless of which approach we use. Widget 1 and widget 2 from here look identical. In fact, using the public field could even be considered better. It uses far fewer lines of code, meaning that that class is much easier to read and understand. So why don't we just do that? Well, as you may have guessed from the title of this video, the answer is, of course, to do with encapsulation. Member fields are data that belongs to that class, and so we shouldn't just make them publicly available to anything that wants to access or change it. We want to encapsulate that field so that the class in question has full and exclusive control over it. It's then up to the class how it chooses to expose the field, if at all. Consider if we decided that actually we wanted to store the ID as a string now rather than an integer. Of course, we can do that for our first widget with the public member field, but then everything that used that field must be modified to work with it as a string rather than an integer. We can say that anything that accessed the field was coupled to the member data of the class, and so making a change to it becomes quite painful. For our second widget with a public property, life becomes much easier. We can change the field to be a string, but can keep the property as an integer so long as we perform the necessary translation in the property as shown. Nothing got coupled with the member field, just with the property, so we can change the field as much as we want. We can even remove it entirely, so long as we do something sensible in the property so that some data is still returned. Just to drive the point home, this is what we're left with. Our calling code doesn't see anything different following the change to our well-encapsulated widget 2, but it must be changed to support our poorly encapsulated widget 1. Of course, it goes further than that. Our encapsulated class also becomes the gatekeeper for its own data. Whereas widget 1 had to accept any ID that was forced upon it, widget 2 has greater control. It can reject any data it doesn't like, either silently ignoring it, as in this example, or throw an exception if required. We can even remove the ability of external code to write to the field at all, and this is very important in encapsulation. Our encapsulated class will only allow the writing and even reading of data that makes sense given the class's purpose. In addition, only methods, events, and properties that support this purpose will be available to external code. It might make sense for a class to have a utility method that strips hyphens out of a string, but unless this is the stated purpose of that class, the method should be kept private or protected so that it can't be accessed from external code. So hopefully you're now getting an idea for what it means for a class to be well encapsulated. Certainly we don't want to see any public member fields. Even public properties should be used sparingly. Often it can be better to set data on the class's constructor or through a method. The former allows us to be certain that the data is always going to be available to our class, while the latter gives us better control and may, for example, allow us to set 2 or more related fields at the same time. Also, be very careful when exposing complex types on a getter. Complex types have methods and properties of their own, so you run the risk that external code may use them to modify the data in ways you weren't expecting and that don't make sense for the class. Often it's a good idea to expose just a limited subset of the type's methods and properties directly on your own class. Alternatively, if that seems onerous, you might want to find or create a read-only wrapper around the type. You should also review public methods to ensure that they're in keeping with the aim of the class and don't allow external code to perform actions that don't make sense for your class. So that's all I've got for you this time. Hopefully you now understand what encapsulation is, how it relates to abstraction, and how you can use the concept in your own software. We also looked at why public member fields are a bad idea and what we should do to ensure that our classes are properly encapsulated. I really hope you enjoyed the video. If you did, please take the time to subscribe to our YouTube channel or follow us on Twitter. As always, if you have any questions, comments, or ideas for future videos, just let us know. Thanks for watching.